I've been around long enough to see the development of museums' collection management systems, henceforth CMS, from their earliest days. The original systems, like Grifols and Celgem in the USA and GOS in the UK, were developed with the aim of indexing collections data and of improving access to that data. Although we take online retrieval as a given these days, the early systems often delivered this access in the form of printed, computer-generated listings. From the beginning, the nature of museum data has provided a challenge to standard database techniques. Three features which caused problems were the variability in the amount and complexity of the information recorded, the tension between a form of data suitable for indexing and a form suitable for display, and the challenge of representing uncertainty in a computationally useful manner. The net result is that early systems often adopted unconventional software and database platforms, in some cases inventing a whole new framework to support museum cataloguing. Experimental techniques such as probabilistic information retrieval were applied to museum data. While today's systems have mostly settled down into using more conventional database technologies, the underlying challenges presented by museum data have not changed. Today, you can validly add to these challenges the requirement to cope with multiple languages and scripts. In the early days, even supporting upper and lower case was a challenge. While support for information retrieval has remained a key feature, most systems have developed into a practical management tool that supports the museum's routine work with its collection. In terms of the information recorded, this has meant that a database which started life as a transcription of a catalogue card or accession register entry will now include a raft of administrative and technical data. While this is fine as far as it goes, and it certainly is necessary if the CMS is to be fit for its intended purpose, the CMS tends to be the only place where the museum can record data about individual objects. In this talk, I will explore the potential problems which this might cause. Museums which have the resources to put on special exhibitions and publish catalogues describing the exhibits tend to do so through a separate workflow which has no connection to the collections database. These catalogues typically contain detail about objects in the collection, offering a curator's or external expert's perspective of their significance in the context of that exhibition. However, this new information about collections objects is usually not added to the CMS data about that object. Instead, it goes through a workflow which uses publishing software and data formats and becomes a printed book. The machine-readable source of this publication may not even be retained by the museum. In any case, there is no mechanism for splitting the book into object-level segments and converting these segments into a format which the CMS can ingest. In an ideal world, the exhibition descriptions of each object from the host collection would be available from the collections database. In addition, catalogue descriptions of objects which have been lent for the exhibition by other institutions would be returned to those institutions for the enrichment of their CMS database. This could, for example, be implemented as part of a future version of the EODEM protocol. Most collections catalogues are supplemented by a set of files containing primary sources associated with the collection's objects, correspondence, receipts, shipping documents, and so on. If these sources are catalogued, this will typically be done using archival standards and practice. Any computerized system that is used will be based on ISAG standards and probably encoded archival description. In many cases, this data will be held in a software environment which is separate from the CMS. A similar situation applies to museum libraries. Bibliographic systems have a different cataloging tradition and different software to support it. Creating and then maintaining a presence on social media is hard work. In theory, a CMS can provide a never-ending source of interesting objects to put before the public, but this requires an interface which allows suitable objects to be chosen and the ability to export data in a format which is interesting and which can be published directly as a tweet, Facebook page, or so on. Also, the public are a potentially rich source of additional information about collection objects. They can offer more general recollections, photographs, and background material which relate to and so enrich our knowledge of the societal context in which the collection sits. Ingesting such information into the CMS is doubly difficult. Assuming a technical route has been prepared, there is the challenge of where to place information which may not relate to exactly one collection object. Projects such as linked art are beginning to suggest to museums that they should be in a position to publish information about their collections as linked data. In principle, the CMS should be able to take on this additional role. Assuming that the museum already has a collections website, offering a linked data interface ought to be a simple matter of implementing a different view of the data which is already present, and adding some content negotiation rules. However, one problem CMSs have with linked data is that it works best when items of data are themselves expressed using linked data URLs. The typical CMS will not offer any support for including such URLs in core object data. Another problem is that it can be hard even to find suitable authorities to cite. Also, a standard feature of linked data support is some sort of query interface to the linked data. This is normally provided by a SPARQL endpoint, which in turn implies that the linked data is stored in a triple store and not in a standard relational database. It's not feasible to extend the CMS so that it can support all of these additional requirements. The job it already has of supporting the management of a museum collection is quite challenging enough. So, how does a museum extend the reach of its digital offer beyond the capabilities of its CMS? 3 elements: export, import, and subsystems. Where a museum wants to do something with CMS data which is not supported by their system, the obvious way forward is to pull relevant data out of the CMS and introduce it to other software which can do the required job. This requires the CMS to have the ability to select relevant records and then export them in a useful machine processable format. Typically, this format will be something like JSON, XML, or a comma-separated file. For example, Bristol Museum export records from their KEMU system as JSON and use this data to support digital signage, exhibition scheduling, and gallery interpretation applications. The modes system provides the ability to export selected data as CSV or XML. However, repurposing data in this way presents a number of challenges. First, over time, the extracted data will become increasingly out of date as the core CMS data is routinely updated. This suggests the need for an automated means of refreshing the exported data, for example, by means of a timed script. Second, the whole approach assumes that the required data is already in the CMS and is in a format which can be directly processed by the consuming application. The aspiration to create once, publish everywhere, COPE, brings with it the requirement to record all the information which is required for all purposes. Where required data is missing from the CMS, staff will need to be briefed on the additional requirements and the retrospective cataloguing exercise undertaken. As already noted, a data format which works well for analysis and processing may not work so well as a display format, and vice versa. A level of description which is appropriate for one audience may not work for a different audience. Third, the external application framework which is chosen may not age well. Web development frameworks come and go, and there is no obvious choice which can be guaranteed to be supported, say, 5 years hence. Museums tend to do their information processing across a much longer timescale than a typical web developer. Then there's getting data into the CMS. Exporting data for use in an external application is perhaps the easy bit. So long as the data is provided in a processable format, the onus can be placed on the receiving application to make sense of the structure and, if necessary, reformat the data. When external data is presented for import into the CMS, the roles are reversed. Either the CMS provider or the museum's CMS admin needs to work out a mapping between the external data and the internal CMS data structure. They must then implement that mapping as a procedure which can be run whenever this type of data is presented. For example, we expect that CMS providers will implement import mappings for EODEM data on behalf of all of their users. Where the CMS has been designed with the expectation that it will routinely receive and import data, some form of generic data transformation tool will be provided. For example, in the mode system, which is XML-based, we provide the ability to associate an XSLT transform with a specified type of import. However, this still makes two assumptions: that the data to be imported will be well-formed XML, and that someone will write the required XSLT transforms. The web offers a variety of services which can potentially take the load off the CMS. This applies particularly to images, which take up lots of storage space and present copyright and other rights issues. Apart from generic services such as Reddit and Flickr, there are options which have been developed with the cultural heritage community in mind, such as HistoryPin. Some of these services are free. External services can also provide ready-to-run functionality, such as the Google Maps API. The key question to consider about such a service is what would happen to your resources or user interface if the service is withdrawn or the terms of service changed. It is arguably unwise to rely completely on an external service by using it to hold the only copy of your resources. For services which provide functionality, you should consider what formats might be available. For example, OpenStreetMap for a mapping interface. Descriptions of objects involve complexities which are not satisfied simply by providing a free text field in the CMS database. The publication of exhibition catalogues, which I mentioned as an old problem, is just one example of this. Written text contains headings, cross-references, footnotes, illustrations, etc., all of which require an authoring environment which is as capable as a word processor. The text authoring subsystem could take this load off the CMS and provide the museum with a means of producing both traditional print publications and, for example, object labels. It could take as its input object data exported from the CMS to save retyping of core information. Ideally, such a system will support links to the part of a text which describes a specific object. Some museums have been experimenting with the use of wikis as a platform for their text authoring work. To Twitter and Facebook, the current two most widely used social media platforms, both have APIs which allow targeted queries and which return a JSON response. The structure of these responses is specific to each application, so it makes sense to set up a database specifically to hold social media interactions which are of interest to the museum. This might be a non-SQL database such as MongoDB or Couchbase, which can deal natively with JSON data. Where these interactions relate to specific objects in the collection, identifiers such as Twitter hashtags can be used to make a link between the object record and its discussion on social media. While there are tools for extracting tweets which mention specific objects, these will only appear on Twitter in the first place if the museum starts a thread by seeding the discussion with tweets mentioning them and inviting comments. My inquiries while researching this talk did not unearth any systems for interfacing between CMS and social media platforms. This seems like a missed opportunity. If museums want to present a coherent view of their own collections in a broader context, I believe that they need a separate linked data subsystem. As already noted, even the core museum, library and archive data held by the museum itself will be recorded using radically different approaches. Much of that data is administrative and/or confidential, and so is not to be shared. A linked data store provides a neutral platform into which shareable object, bibliographic, and archival data can be exported. There, these data can be re-expressed in a way which brings together different statements about the same entity, object, person, historical event, etc. Linked data offers a way of recording detailed information relating to collections objects which goes beyond the levels supported by the CMS. For example, the linked art group is working on detailed models for provenance, sale history, and so on. A linked data store also provides a place where the museum can include non-object data relevant to its broader purpose. For example, for a local history museum, details of local personalities, industries, and places, and allows you to link these entities to collection objects. Information about objects to be loaned or exhibited should rarely end up being managed within the collections management system. The emergence of interchange standards such as EODEM means that it is becoming possible to design interfaces for exporting and importing such information in an efficient manner. The automated transfer of object details and requirements will save museum staff time that was previously spent copying data from custom spreadsheets or even retyping it by hand. In this case, the interface can be implemented simply by applying the export and import facilities which we have already established that the CMS needs to have. EODEM uses the Lido format, and it is interesting that in the UK this format has also been adopted by the Art UK aggregator project. Once the basic tooling is in place to support the export and import of Lido data, it is possible that this format will also be used for other collections management interchange purposes. It is already used by Europeana. My conclusions from this scan around the actual and possible uses of CMS is that they need to ensure that they provide adequate export, import, and linking facilities. This will mean that users can develop arm's-length subsystems without reference to the CMS supplier, to the advantage of both. The export process should include selection of the records to be exported, specification of the data to be included within each record, and ideally some choice over the format in which data is exported. It should be possible to express a complete export as a script so that the same export can be run on a regular basis, allowing the contents of a remote copy of the data to be kept up to date. Import requires a facility for mapping incoming data to specific fields in the CMS data structure. It may be that the greater complexity of an import process means that it has to be supported at the product level and maybe only for widely adopted formats such as EODEM and potentially generic LIDO. Linking offers the potential to tie together the core CMS records with satellite data held in the sort of homegrown subsystems we have been outlining. The single most important contribution that the CMS can make on the linking front is to generate a unique, persistent, dereferenceable URL for each object in the collection. Dereferenceable simply means that if you type that URL into a browser address bar, you will get a description of the object in question. These object URLs can then be used in satellite systems as a foreign key for the object in question. This, in turn, makes it straightforward to link from the CMS to all mentions of a specific object in satellite systems, such as all the passages of text which describe this object. Indeed, it allows links to mentions of that object anywhere on the web. If the museum's objects have persistent URLs, these can be quoted in any online context. Linked data URLs return machine processable data. The object URLs provided by the CMS will be much more useful if they can do this, either by following the linked data content negotiation guidelines to deliver RDF versions of the object data, or by returning an XHTML page which itself contains microdata or RDFA. CMS systems should also consider providing their users with the ability to include other people's linked data URLs as a standard part of their editing interface. Such links can be used to connect to rich external data sources. They are foreign keys into databases which the museum does not have to maintain. By developing their export, import, and linking capabilities, CMSs will enable their users to extend their system as they see fit, without placing additional demands on the CMS itself. Meanwhile, the CMS can continue to act as the bedrock of the museum's cataloguing efforts. One advantage of what can seem like a glacially slow rate of product development for CMSs is that they provide museums with a stable home for their core data. Thank you.